Today we're at Larry's house and we're going to be reviewing his water system design. He's got a recirculation system that we're going to look at for hot water. Larry, tell me what we're going to see today.
Well, we're going to go over the whole plumbing system for the new house. Everything starts at this well. It's a shallow well. It only goes down about 36 feet and it's got a submersible pump. The water pumps out of the ground here and it follows this line that you see in this trench into the new garage through this pipe right there. There's a T that's buried in concrete. The T goes one leg over to the captive water tank and the other leg comes back here to feed the fresh water for the entire house. So from that well out there, we're going to have fresh water coming in right here. And then when we get to this cross, water can go out through this valve when it's turned on, and this feeds 5 different hose bibs on the outside of the house. It's independent of the rest of the system. At the cross also, there's 2 options here. We can go through the filtering system, which will be in this area here, and it'll go back down in to feed the house. Or if the filter system is being changed, you can shut these valves off and open up the bypass and just bypass the filters altogether and feed the house still. Once the water is conditioned or not, it flows to fresh water to feed all the cold water of the house, which means toilets and sinks and all that stuff. The other option is feeding the hot water system. So we have cold and hot here. This is feeding the hot water heater. And then from the hot water heater, the house is fed through a recirculation system. So what you just saw out there was this fresh water pipe doing the makeup water. So anytime we use hot water anywhere in the house, it's going to come in here and through the hot water tank, which is bypassed at the moment because we're pressure testing. But the water will come in the cold side of the hot water heater and then out the hot side of the hot water heater and then back up through here. And this is a giant loop of hot water that goes through the entire house. So the reason we have a loop going through the house is our kitchen is quite a ways away. We don't want to have to sit there and wait for hot water to get there. And that wastes a lot of water. It's probably more important for places like California where water is actually at a premium and you don't want to waste any. So the recirculation system can really help for not using so many gallons of water in a year. All right, so the hot water circulates through the house in a giant loop, but the recirculation leg for hot water is right here. So this is all one giant loop. And then it returns back to right here. This is the recirculation pump that runs and circulates the water in that loop we just discussed.
Does it stay on all the time?
So they can. I think a lot of people have these running just 24/7 all the time. Their wattage is really low. I think it's like 85 watts. They make them that also have timers on them that only come on specific times of the day. And this one, I'm going to have a sensor that senses the temperature. And if the temperature is already warm, it will shut off. But once the temperature of the returning water drops to a certain point, the pump will kick on again and it'll recirculate till you get back up to that temperature again. So what's happening here is the water is returning from under the floor like we just showed you, coming up into here, coming out, and then back in the other side of the wall to meet up with this pipe, which is the makeup water, cold incoming makeup water. So to make this work right and not have your hot and cold mix, you have to have a couple of check valves. Here's a check valve, and that ensures that water in this cycle, from this pump, is not pushed back into the cold side. So water always has to go that direction. And then there's a check valve right here, so any makeup water, if this pump happens to be turned off, it could very well be that if you turn on a sink, the makeup water, instead of going through the hot water heater on the other side of this wall, you could just run reverse to the sink and you end up never getting hot water. So you have 2 check valves here that keep the hot and cold side from mixing. Because you have a check valve here and here that oppose each other and a hot water heater in the middle, you have a problem in that water expands when you heat it up. It's especially a big problem when you first turn on the system, when you have cold water and you're going to raise the temperature of the water, maybe 50 degrees. It's going to expand, and that 80-gallon hot water heater in there could very easily expand an extra 1 gallon of pressure. Now that pressure's got to go somewhere, and if you have 2 check valves here, that's a problem. So what we've done here is put a captive water tank, just like that giant blue one over there, that can handle that. This is a 2-gallon tank. This is where that extra gallon of water that expands is going to go. It's not going to overpressurize the system and blow off your pop-off valve on you. So I added this valve for purging the system of air, especially at time 0. We'll turn the water on, we'll open this up, and to get all the air out of the system. All the pipes in this recirculation system, we're going to independently insulate those so we're not losing heat along the way.
Larry designed and built this recirculating hot water system for his home. The total cost of his system is $1,094, with about half of that as a labor to install it. The purchased items listed are in the video description below, along with a website you can find the system's drawing and the breakdown of costs. If you enjoy this video, please like and subscribe for more.